So welcome guys. So welcome to NEET World. Yes. So in this session, this session is mainly for the people who are facing difficulties in physics. Okay. Like we are going from basic to the advanced level. What are the important topics are asked in mains as well as NEET. Like repeatedly they are asking in 2025, 24, 23, 22, 21 and for example last 7 to 8 years. So those topics we are going to discuss in the 100 days challenge. So when we are going to complete the 100 days challenge now, you are able to you can able to do the questions in physics. Okay, let us start here. Yeah, am I audible, I guess? Yeah guys, so we will start with graph. Yes, so why this graph, why we need to start with graph first of all, and what is the importance of graph in physics, like what type of graph questions will be asked in the physics. Like for example, if we take the chapter that is like kinematic units, motion in a straight line as well as motion in a plane. So in this topic, motion in a straight line, obviously the question will be based on the graph. For example, if we talk about xt graph, that is position versus time graph, or else vt graph, velocity versus time graph. So they will ask question related to these topics only, like what are the, how a question can make, or question will be asked in types of graph. So that we are going to say in this session. Okay, first thing, graph. So mainly there are two important points in graph. The first point, if you see, the first point, slope. The second point, if you see, area under the graph. So when we talk about the graph, there are two important points. One point is slope, the second point is area under the graph, right? Next thing we'll see, I'll show you the different graph here. For example, x versus t. What is x here? Position, right? So position, x is nothing but position and t is time. Okay, so for example, I'll take a straight line. Okay, so whenever we are talking about slope, slope is nothing but, yes, tan theta. Slope is nothing but tan theta. What is tan theta? We know it is opposite by adjacent, right? What is opposite here? Like if I talk about this is the angle. Okay, this is the angle. See how I am taking angle here, not here. See, whenever we are talking about a slope, the slope line should be made with horizontal, with respect to horizontal, right? So for example, whatever the graph is given, any graph is given, if I want to draw the slope with respect to horizontal, I should take the angle. Okay, okay, I hope you got clear about why we have taken the theta. Now if I talk about the theta, that is tan theta. What is tan theta? Opposite by adjacent, right? What is opposite here? So let me take this opposite, that is delta x, like change in position. Okay, not change in position, like delta x I'll take, and this one as delta t, like small amount of position and small amount of time I have taken. Okay, if I talk about tan theta, tan theta, which is nothing but delta x by delta t. What is velocity? The meaning of velocity we know. Velocity is nothing but, it is position by time, like meter per second is the unit we know. Like if you see this case, displacement by time, right? A displaced object has been displaced with respect to this much time, we will say. That's what, when I talk about the slope, for x versus t graph, I will get velocity. So I will write here a tan theta for xt graph gives velocity, right? I hope you got the term. What is delta x by delta t? Like displacement by time is nothing but velocity, right? So whenever we are talking about a slope for x versus t graph, we get velocity. Similarly, if you talk about, like if we take v versus t, what is v? V is nothing but yes. So v is nothing but velocity. So time t is nothing but time as it is. Okay. Now if I take some line here, some line I have taken. So what I said, the first condition, like whenever we are talking about the slope, the angle should be with respect to the horizontal, right? So here the angle tan theta I should mention, like tan theta. Tan theta is nothing but slope now. So we are talking about the slope. So tan theta will be here. So if I take this one now, that is delta v. This one is delta t, right? So tan theta is equals to del v by del t. Okay. I'll give you a question here. What is del v by t? Like velocity by time. So who are watching now, you can give answer in the comment boxes. What is v by t? Yes. Yeah guys. So it is nothing but acceleration. Like rate of change of velocity with respect to time, we will say no. So velocity by time is acceleration. So what we have learned here in the two graphs. So I'll take a new page here. So what we have learned, when I talk about x versus t, so a slope is there, theta. So slope for this graph gives velocity, right? That is tan theta is equals to delta x by delta t. So del x by del t. So del x by del t is nothing but velocity. That's what we have got here. So the second thing what we have talked about, that is v by v and t, vt graph. This is xt graph, we will say xt graph, and this is vt graph. Okay. Now I have taken a line here. That's the thing we have seen. So slope for this graph gives acceleration. So why I am saying acceleration? Tan theta is equals to, that is delta. Here if you see, this is delta v and this is delta t. So del v by del t. So if I talk about velocity by time, it is nothing but acceleration. So that's why a slope of vt graph gives acceleration. Okay sir, we have said about what is the slope, but is slope increasing or decreasing? How we can find it? Yes, we will find it. See, you can take a note of this or take a screenshot of this. Yeah. Now suppose for example, keep in mind simple thing, if theta is less than less than 90, okay, theta is less than 90, theta equals to 90, theta is greater than 90. Three condition we will take. So the case number 1, like condition number 1 is theta is less than 90, condition number 2 is theta is equals to 90, condition number 3 is theta is greater than 90. So whenever a theta is less than 90, see here in this case now, is theta is less than or greater than? Yes, it is less than 90. See, this is 90 degree, no? When I talk about only theta, it is less than 90, right? Yes. So when theta is less than 90, slope is positive. Slope is positive, right? Now I go for third condition. Next I will come for the second condition. If theta is greater than 90, Simple thing, keep in mind, slope is negative. Now the second condition what says is, like if theta equals to 90, if theta equals to 90, no, it is 0. Okay, keep in mind. So three conditions are there. Okay, take a note of this. Okay, now we will see in a graph how we can analyze. For example, let me take a graph like this. First graph, this is the first graph. Second graph is, it's going like this, going somewhere like this. Okay, third graph. Okay, third graph. So whatever we are talking here, let me take xt, here also xt, xt. First we will analyze whether a slope is positive, negative or 0 or rest, whatever it is, or a constant thing. Now in this case, now I will take like this a line. The fourth case, totally I will take a 4 cases and we will analyze it. So x and this is t. So in this case I have taken it going somewhere like this, it is going upward, but in this case I will take somewhere going down. See, like I am throwing like this, this one I am throwing like this. Okay, understood na? Now what I said, if I want to find theta or a slope, I should take theta with respect to horizontal, no? Yes. If I talk about theta, no, in this case, yeah, this is theta. Okay, at this point, if I talk about this point, no, let me take a horizontal line. Again, if I see theta here, theta, like this theta number 1 I will take, theta number 2 I will take. Whether theta 1 and theta 2 is changing or remains constant. Yes, like when I take this line, no, t and this one yellow line, no, both are parallel and this line is continuous as it is. So theta 1, theta 2 will be equal only. So in this case, like what xt graph talks about velocity, right? So in this case velocity is constant, we will say. Okay, velocity constant we will say. So your slope is constant. Yeah, let me draw this in the next page. Yeah, these two I will take in next page, guys. Okay, slope is constant, slope is constant. Now what we have talked, xt graph, slope gives velocity, right? Take a note of this. ft graph gives xt graphs give velocity. Okay, so slope is constant, so slope is nothing but velocity, then velocity is constant. I hope you got it, right? So velocity constant, that's it. Now we go for the second thing. Second thing, if I take an angle, in this case here theta 1. Okay, now if I take this point, no, let me take this point as some a and this point as b. Okay, so draw a horizontal line parallel to t, right? Now draw a tangent like this. If I draw a tangent like this, I will get theta 1. If I draw a tangent here, I will get theta 2, right? If I draw a point C, like if I take a point C here, if I draw a tangent here, yes, so here theta 3. So now you say theta 1, theta 2, theta 3, are they same or different? Here you can give a comment in the comment boxes, guys, like whether the thetas are same or different. Yes, so theta 1 is not equals to theta 2 is not equals to theta 3. This is the thing, right? So one thing, understand, whenever we talk about sine and tan, like from 0 to 90, 0 to 90, sine and tan increases. From 90, like 0 to 90, cos decreases. Keep in mind, it will be useful in both physics as well as maths. So 0 to 90, I am going from 0, 10, 20, 30, 40 like angles. So from 0 to 90, sine function and tan function increases. When I talk about cos function now, from 0 to 90 it decreases. So what we are talking about here, like tan function only, no, slope. So slope here, slope is nothing but tan, so tan theta. Here tan theta increases or decreases? It's increasing, right, it's increasing. So what I can say here, yeah, slope is increasing, slope is increasing. Whether slope increases, velocity increases? Yes. So xt graph gives, xt graph slope gives velocity, okay. So xt graph slope, in this particular graph slope is increasing, so velocity also increasing, right. Yeah, we will go for the next two graphs. So you can able to understand whether I can identify a graph is increasing or decreasing functions, okay. So listen guys, here I will take x t, right. So two graphs I told, no, one is some parallel line with the t, second one is I am throwing some stone, it is going somewhere like this, okay. Okay, now if I want to take an theta, right, like angle with respect to this, here listen here, in this case no, whether x is changing, whether x is changing with respect to time. See, let me consider me itself, I am at position A position, I am not moving, but time changes, okay, time changes, but a speed of a minus like 10 meter per second, simply I am walking or jogging like this, okay. But what they are saying is like position doesn't change with respect to time, it means velocity 0, right. So if we take a slope for this also, it is 0. Understood guys? Whether whenever y axis point is parallel to x axis, now simply say that 0, slope is 0, body is rest, body is rest. Understood? Now the final graph, the fourth graph we will talk about. See here, what is the first point I said? I need to draw, I need to take a point, okay, I will take a point, yeah, let me take this point, okay, this is the horizontal line, okay. So next point what I should do, yeah, I need to take a tangent, right, draw theta here, simple na, take horizontal line, whichever point you need, draw a tangent over there, take theta. So let me consider this is theta 1, this is point A, this is point B, okay, this is point B, take horizontal line, again draw a tangent like this. So if I see here tan theta, this is theta 2. So by seeing the image, no, you can able to identify whether theta is increasing or decreasing, or this one and this one are looking similar or different, whether this angle is bigger or this angle is bigger, or comparatively I need to analyze it. When I analyze this one now, for point A theta 1, for point B theta 2. So if I see theta 1 is greater than theta 2. So what I can say from this graph, if I go from point A to point B or point B to point C, the angle is goes on decreasing, right, goes on decreasing. So if theta decreases, what I can say, slope also decreases, right, slope also decreases, yeah. So slope decreases. What is slope? Slope is nothing but velocity for xt graph. So velocity also decreases. Right. One more point you need to understand here, no, like velocity increasing, right? Velocity increasing. When velocity increases, guys, like you are driving a bike, right? Driving a bike from one point to another point. Let me take from Hyderabad to Vizag. You are going, okay? What you are saying, like velocity increasing or speed increasing, what you will do? You will accelerate it, right? So in this case, acceleration increases, right? If you take the velocity increase, like if you consider velocity increases, acceleration also there, right? But if you talk about this one, no, acceleration decreases, like velocity decreasing, right? Acceleration also decreases. What you will call that point? It is retardation, we'll say. Okay, it is opposite of acceleration, right? So retardation. So keep in mind, in this case, no, when velocity increases, acceleration increases. In this case, when velocity decreases, acceleration also decreases. That name is called as retardation. Understood? Take a point of this. Hi Deepanshi, hi. Okay. Okay guys, now we talked about this graph. Okay sir, sir, suppose a graph is given and the given option was not possible. How, what, like we have talked about 4 graphs sir, but none of the graphs are not possible we have talked, but whether some answer has been came. A not possible graph. Arey yaar, what is this not possible graph? Let me explain this. Not possible. Okay, this graph is not possible. See, when I talk about displacement, no, it can be negative or positive, right? But when I talk about the distance, whether distance is negative, I can like from here to like Hyderabad to Vizag for x kilometer, for example 500 km, let me take, okay. Again I have made a round there and I return back, okay. Will I say this is my like displacement will be 500 minus 500, but when I talk about the distance, it is 1000, right? 1000. So going 500, coming minus 501, will I say like that? No, no. When I talk about the distance, it is not a negative thing. See, same thing I am explaining here. See, take a graph that is distance versus time. Okay, distance versus time. See, this is the graph given. This is the graph given. Initially, this is 10 meter. Let me take. Okay, like for example, person A, okay, want to go from hotel or from his room to gym. Okay, from his room to gym. It is 10 meter. Let me take. When you open the Google map, no, it will show. You need to go right, left, whatever things, but you need to go within like in a 10 meter. So when you are going, distance decreases, right? So it has decreased. It has reached 0.0. Points like 0 meter. I mean 0 meter. Okay. What it means? You have reached the destination, right? But if you go, will you go minus 10 meter? Will you go minus 10 meter? It's not possible, right? That's what the graph says. It's not possible. But the same, one more thing is like x versus t graph is there. X versus t graph is there. We have talked about this parallel line with respect to horizontal, sir. But if I take a parallel line with respect to vertical, what is the point, sir? Simple, guys. Simple thing. Okay. When I take this, yeah, let me draw here. When I take a line like this, if I draw a slope, I will get angle as 0, theta equals to 0, right? What is tan theta? That is 0. But if I take a line parallel to x axis, no, see 90 degree, right? Tan 90, undefined, it's infinity, it goes somewhere, right? So it's not possible. This also not possible. This also not possible. So these are the two graphs which is not possible, we'll say. Understood? Yeah. Take a note of this. Okay. Okay, sir. You have talked about like position and time, sir. What about velocity and time? And you have said something called area under the graph. What is that, sir? What does that mean? Yeah, let me talk about that. See, this is v versus t, velocity versus time. The same thing I will take here. Some line I have taken. Okay. If I got theta here, what is theta? That is slope, right? Theta is nothing but slope. For what slope, sir? How we can say, like, what is the purpose of the slope here? See, if I talk about the x-axis, sorry, y-axis, it is delta v. When I talk about the x-axis, it is delta t. What is slope? It is nothing but tan theta, right? Yeah. Tan theta is equals to opposite by adjacent v by t. What is v by t? Simple, right? Acceleration, right? So what you can understand when you talk about velocity versus time graph, it is acceleration. Simple thing, the first point you can understand. Here, if I talk about this slope, this is theta 1. When I take a parallel line, and if this point number B, this point A, object goes from point A to point B and point B to point C. If I draw tan, like slope, if I want to calculate the slope, this is tan angle theta, that is theta 2, this is theta 3. So whenever I am calculating now in this graph, theta 1 equals to theta 2 is equals to theta 3. What you can understand? Slope is constant. Slope is constant, right? So slope is constant means, so what is slope here? That is delta v by delta t. Acceleration, right? So acceleration is constant. So you have accelerated, but you at some point you stopped acceleration, but you are moving. See, initially from 0 to 50 kilometer per hour you accelerated, but after that you didn't accelerate. Will a body or object move, or it will be stopped? It will move, right? It will move. That's what acceleration is constant. It's moving. It's moving. Point A, point B, point C, point D. It's going somewhere. Wherever you want, you can go, right? Yeah. So when I talk about V versus T, okay, V versus T, this graph, I am throwing something like this, yeah, this one, like this, understood? So for this, no, if I talk about the angles, so this is point A, and this is point B, and this is point C, this is point D. For this one, this is point small a, B, C, D, sorry, D, right? Okay guys, this is theta 1, yeah, this is theta 1, this is theta 2. Draw a line parallel to x-axis, this is theta 3, draw a line parallel to x-axis, theta 4. So when I see this, no, in this theta are increasing. What I said, whenever you are taking a tan theta or a sin theta, whether angle increases, a function also increases. That's what, no. So theta 1 less than theta 2, less than theta 3, less than theta 4, right? That's what, no. So slope increases. What is slope? Acceleration. Acceleration also increases. Understood? So in this graph, acceleration increases. If I talk about this graph, take a horizontal line, draw, like I need to draw tangent first, right? Here also I need to draw tangents. Don't forget it, draw tangents, okay? Draw tangent, theta 1, this one, theta 2, this one, theta 3, this one, theta 4, right? Theta 4. So when I see here, theta's are decreasing, right? If slope, that is tan theta, decreases, theta decreases, what does it mean? Acceleration decreases, acceleration also decreases. So this is about the slope of VT graphs, right? So now comes for the area under the graph. You can take note of this. Okay, fine. See, listen guys, the same thing, but I will take sir, you have talked about XT graph, sir, VT graph, sir. What about AT graph, sir? Whether there is a slope for that? Sir, no, sir, there is no slope. There is no slope for the AT graph. But I can find one thing. Okay, see, this is A and this is T. This is A and this is T. If I talk about the area, no, this is the area, right? This is the area, right? So what is the meaning of area in this case? You can say, I'll give a simple trick, guys. Simple trick. Whenever you are dividing the axis, no, y axis by x axis, you will get a slope. Okay. See, listen. I'll take a note point. Note point. Whenever or you divide y axis by x axis, you get a slope. Now the point is, whenever you will multiply y axis and x axis, y axis into x axis, you will get area under the graph. Okay, sir, you talked about slope. We got what is slope, sir. We understood, like a slope for VT graph or XT graph. If I take a area for VT graph or AT graph, what will come? Simple, no? Like what I told, y axis into x axis, right? What is here? What is y axis here? Acceleration, right? Keep acceleration. Multiply the x axis into time. So what is the meaning of acceleration, guys? It is velocity by time, right? First thing. The second point is velocity by time into time, right? So time cancel. What I said, when I talk about area under the graph, it is multiplication. I will get velocity for AT graph. So if I take a area under AT graph, I will get velocity. Similarly, when I talk about VT graph, V versus T graph, right? So yeah, this is the line. I have taken simply some lines. Okay, this is the area. What I said, velocity into time, that is x axis, sorry, y axis into x axis. What is velocity? It is displacement by time. Displacement by time. Our position will say like time will get cancelled, will get displacement. Understood? The thing, first thing is what is slope, and second thing is what is area under the graph. How I can find slope? By dividing y axis and x axis. How I can find area? By multiplying both the axes, right? I hope you got some confident about doing the graph problems. Let me give an example here. Yeah, try this example and give answer in the comment boxes, guys. See, object starts from point O. It's moving somewhere to point A, and again point B, it has been moved, again came to point C here. Okay, so let me take this as 0, 0. Okay, this one somewhere 5. This one again I will take 10, and this is 20 I'll take, and this is the point C, that is 35. Understood? 5, 10, 25, 30, sir. Why you are taking uneven number, sir? Do guys, do the question. Okay. So this number I will take 20. Okay. Now the graph, what is this x axis and y axis, sir? You didn't mention that. Yeah, I will mention it. A T. So area under the graph, what you will get? You will get velocity, no? Acceleration versus time. Yes or no? Acceleration into time, velocity by time into time, I will get, time will get cancelled, velocity I will get. So if I want to find the area, there is this, no? This one looking like, is this looking like triangle? Similarly, this also looking like triangle, no? So two triangles are there, and this one rectangle. So you can find the area of triangle and rectangle, everything you can add it. So you will get the velocity. Okay. Okay guys, thank you. You will we'll meet in the next class. Exactly tomorrow we'll meet by 5:50. Right. Okay. You can give answer in the comment boxes, guys. Don't forget it. Okay.